Hello guys, welcome to my channel with JR of Talents, and in the previous video we have learnt about rational numbers, and in this video we'll be learning about irrational numbers. So without further delay, let's get into the topic. So, irrational numbers. If a real number cannot be written as a fraction of two integers, that is, it is not rational, it is called an irrational number. A decimal that can be written as a fraction either ends, terminates, or forever repeats, about which will be seen in detail further. So, real number pi is an example of irrational. The value of pi is 3.1415936535897. Oh, it's so long. Then the number neither start repeating themselves or come in a specific pattern. So let's look at the first point. The real numbers which are not rational are called irrational numbers. The point 2, the square roots, cube roots, etc. of natural numbers are irrational numbers if their exact value cannot be obtained. And the third point is all non-terminating, non-repeating decimals are irrational numbers. The fourth point, pi is an irrational number as we have seen earlier. Then fifth point is if m is not a perfect square, the root m is irrational. The sixth point, if a and b are two positive numbers such that ab is not a perfect square, then 1. A rational number between a and b is a plus b by 2. 2. An irrational number between a and b is root of ab. So let's see more points regarding irrational numbers. The first point is for any two positive rational numbers x and y, root of x square is equal to x, root of y square is equal to y, root of xy is equal to root x into root y, and whole root of x by y is equal to root x by root y. If root x and root y are irrational numbers, then root x is greater than root y, that is, x is greater than y. And if root x and root y are irrational numbers, then x is greater than root y, that is, x square is greater than y, and y is greater than root x, that is, y square is greater than x. The second point is if a plus b root x is equal to c plus d root x, then a is equal to c and b is equal to d. The third point is the negative of an irrational number is always irrational. The fourth point is the sum of a rational and an irrational number is always irrational. The fifth point is the product of a non-zero rational number and an irrational number is always irrational. The sixth point is the sum, difference, product and quotient of two irrational numbers may not be an irrational number. I hope that you have understand about irrational numbers. So now let's see how to locate a irrational number on number line. So if we see the first question, locate root 2 on the number line. Now let's go to the solution part. It is easy to see how the Greeks might have discovered root 2. Consider a square OABC as you can see in figure 1.6 with each side 1 unit in length. Then we can see by the Pythagoras theorem that OB is equal to root of 1 square plus 1 square, that is nothing but root 2. How do we represent root 2 on the number line now? So that is very easy. Transfer figure 1.16 onto the number line, making sure that the vertex O coincides with 0 as you can see in figure 1.7. We have just seen that OB is equal to root 2. Using a compass with center O and radius OB, draw an arc intersecting the number line at the point P. Then P corresponds to root 2 on the number line, and we have got the answer. Let's see another example. So this question is locate root 3 on the number line. So let us return to figure 1.7. Construct BD of unit length perpendicular to OB as we can see in figure 1.8. Then use the Pythagoras theorem. We can see that OD is equal to whole root of root 2 whole square plus 1 square is equal to root 3. Using a compass with center O and radius OD, draw an arc which intersects the number line at the point Q. Then Q corresponds to root 3. I hope you might have understand all the topics in irrational numbers and how to draw a number line representing an irrational number. So without delay, let's solve the exercise 1.2 which is on page 8. So the first question in it is state whether the following statements are true or false just by your answers. The first bit is every irrational number is a real number. So the solution for it is true. Irrational numbers definition is a number is said to be irrational if it cannot be written in the form p by q, where p and q are integers and q is not equal to 0. That is, irrational numbers are 0, 19 by 30, 2, 9 by minus 3 and so on. So now let's see the definition of real numbers. The collection of both rational and irrational numbers as known as real numbers. That is, real numbers is equal to root 2, root 5, pi, 0.102 and so on. Therefore, every irrational number is a real number. However, every real number is not a irrational number. So the second question is, every point on the number line is of the form root m, where m is a natural number. So let's go to the solution. So it's false because the statement is false since as per the rule a negative number cannot be expressed as square roots. Example, root 9 is equal to 3, that is a natural number, but root 2 is equal to 1.414, that is not a natural number. Similarly, we know that there are negative numbers on the number line, but when we take the root of negative number, it becomes a complex number and not a natural number. Example, root minus 7 is equal to 7i, where I is equal to root of minus 1. Therefore, the statement that every point on the number line is of form root m, where m is a natural number, is false. So now, we see the third bit. The question is, every real number is an irrational number. So the solution for it is false. The statement is false since real numbers include both irrational and rational numbers. Therefore, every rational number cannot be an irrational number. The definition of real numbers is the collection of both rational and irrational numbers are known as real numbers. That is, real numbers is root 2, root 5, pi, 0.102 and so on. Irrational numbers definition is a number is said to be irrational if it cannot be written in the form p by q, where p and q are integers and q is not equal to 0. That is, irrational numbers are 0, 19 by 30, 2, 9 by minus 3 and so on. Therefore, every irrational number is a real number. However, every real number is not irrational. So let's go to the second question now. Are the square roots of all positive integers irrational? If not, give an example of the square root of a number that is a rational number. The solution for it is no. The square roots of all positive integers are not irrational. For example, root 4 is equal to 2, which is rational, and root 9 is equal to 3, which is also a rational number. Hence, the square roots of positive integers 4 and 9 are not irrational. So now let's look at the third question. Show root 5 can be represented on the number line. So let's look at the solution. Step 1. Let line AB be of 2 unit on a number line. The second step is at B, draw a perpendicular line BC of length 1 unit. Step 3. Join CA. Step 4. Now ABC is a right angled triangle. Applying Pythagoras theorem, AB square plus BC square is equal to CA square. 2 square plus 1 square is equal to CA square. Therefore, CA square is equal to 5. That is, CA is equal to root 5. Thus, CA is a line of length root 5 units. The step 4 is taking CA as a radius and A as a center, draw an arc touching the number line. The point at which the number line gets intersected by the arc is at root 5 distance from 0 because it is a radius of the circle whose center was A. Thus, root 5 is represented on the number line as shown in the figure. So now the fourth question is classroom activity. Constructing the square root spiral. Take a large sheet of paper and construct the square root spiral in the following fashion. Start with a point O as drawn a line segment OP1 of unit length. Draw a line segment P1, P2 perpendicular to OP1 of unit length. Now you can see it in figure 1.9. Now draw a line segment P2, P3 perpendicular to OP2. Then draw a line segment P3, P4 perpendicular to OP3. Continuing in figure 1.9. Constructing this manner, you can get the line segment Pn-1, Pn by square root spiral, drawing a line segment of unit length perpendicular to OP, N1. In this manner, you will have created the points P2, P3, Pn and joined them to create a beautiful spiral depicting root 2, root 3, root 4 and so on. Now let's look at the solution. So you can refer to this picture while drawing it. So let's see how to draw it step by step. Step 1. Mark a point O on the paper. Here O will be the center of the square root spiral. Step 2. Form O. Draw a straight line OA of 1 cm horizontally. Step 3. Form A. From A, draw a perpendicular line AB of 1 cm. Step 4. Join OB. Here OB will be of root 2. Step 5. Now from B, draw a perpendicular line of 1 cm and mark the endpoint C. Step 6. Join OC. Here OC will be of root 3. Step 7. Repeat the steps to draw root 4, root 5, root 6 and so on. I hope that you all had understand the topics which I have learned in today's video. Please don't forget to subscribe my channel and click on the bell button. And please do like my video. Thank you for watching it.